Hey everyone, we're going to determine if the series is conditionally convergent, absolutely convergent, or divergent. We're going to use the ratio test. I have this on my Facebook page if you want to save this. This gives you the definitions, but basically I'm going to write it out. We want it for it to be absolutely convergent. Here, we're going to take the limit as n approaches infinity of absolute value of a sub n plus 1 divided by a sub n. Now if that equals some limit that is less than 1. If that equals that, then it's absolutely convergent. So let's fill this in. We're going to get the absolute value of negative 1 to the power of n plus 1 times, for this piece here, that's going to end up being n plus 2 times 3 to the power of n plus 1. Divided by, and then for this piece, that's going to be 2 times 2n to the power of 2n plus 3. Again, this is, all you have to do is add the 2 to this 1, or you can write n plus 1, distribute, and you'll get the n plus 3. Now, we're dividing by a sub n, which is the same as multiplying by the reciprocal. So multiplying by the reciprocal, that's going to be 2 to the power of 2n plus 1 divided by negative 1 to the nth power times n plus 1 times 3 to the power of n. Now, all we have to do is simplify this. So we can get the limit as n approaches infinity. And let's look at this piece right here. This is just going to equal, if I write this out, negative 1 to the power of n plus 1. And then this piece here is going to be minus n, using your powers of exponents. So basically you get negative 1 to the first power. And when you take the absolute value of that, that just equals 1. So basically we can kind of ignore those. Now, let's look at our 2's. I'm going to go ahead and put a line here. Let's look at our 2's here. We have 2 to the power of 2n plus 1. So this is 2 times 2 to the power of 2n. Divided by, this one is going to be 2 times 2 times 2 times 2 to the power of 2n. So basically this 1 means we have this extra 2 here. This 3 means we have extra 3 2's. Now what happens is these two cancel. This cancels. So 2 times 2 is 4. So that takes care of those. And those were the 2's. All right. We still have the n plus 2 in the numerator. And in the denominator, we still have n plus 1. So now what's left is this 3 thing here. So again, this is going to be 3 times 3 to the nth divided by 3 to the nth power. So that's just going to give you 3. I can put that in the numerator. All right. So that takes care of all that. Take care of them separately, and it makes it easier. All right, so this can be written as 1. Let's write the limit as n approaches infinity of 3/4 times, let's divide everything by n, so you get 1 plus 2 divided by n, and then 1 plus 1 divided by n. Well, this part here, when you evaluate the limit as n approaches infinity, this just equals 1. So we get 3/4 times 1 equals 3/4. Now that is less than 1, so that means this is absolutely convergent. And that's it. Thank you. Have a nice day. Bye-bye.